Esta conferencia comenzará a grabarse.
Oh, muy bien. Muchas gracias. Okay, so I want to, yeah, we do every language in Veeam. Well, I'm not in Veeam, but Patricio does. Okay, so we're here today to talk about Kubernetes disaster recovery with Kasten. And to do that, I want to introduce this new series that we've got, which is Kubernetes Champions. And what it is we're going to interview Kubernetes champions who work in Veeam. And there are a lot of them. I was surprised because, you hear about Kubernetes, but a lot of these people are working at it, doing it, but you don't always see them posting. Now, Patricio does post a lot, and he's posted some fantastic examples of how to automate disaster recovery. And so we brought him in here today. I wanted to ask, first of all, before he shows us a demonstration, to introduce himself, tell us how he started in IT, why, how he got interested in Kubernetes, and anything else he thinks might be interesting.
You wanted me to tell my whole story.
Your whole life story. Well, you can you can parse it.
Hey guys, I'm Patricio Cerda. I'm a senior solution architect for Veeam. I joined Veeam in 2021, just after the pandemic, and it was just a bit after Veeam acquired Kasten. So at the time, it was a very hot topic, Kasten and Kubernetes. I knew a bit about Kubernetes before, but I was kind of a newbie. But I decided I decided to deep dive into this world, which is very different than I was used to work with, usually with VMware, Hyper-V, even a bit of Nutanix, but Kubernetes is a whole new thing. The interesting part is at least our solution is very easy to use, but most interesting is how to automate, of course, some of the tasks. And actually, this is the main focus of this session. Especially because during a disaster, as you well know, Geoff, if you get a call in the middle of the night, you want to deal with this as fast as you can. You don't want to go very slow with one task at a time. So that's why my idea was always try to see how to automate this task. It's very easy. There are many tools because Kubernetes is designed for automation. And of course, Kasten was designed to work on Kubernetes and is compatible with all the Kubernetes APIs. So every automation tool you have out there for Kubernetes can work also with Kasten. So Geoff, I don't know if you want to add something else before I continue with the presentation.
No, that's great. And again, I think one thing I want to underline here, when I started working or playing around Kubernetes, I did notice that there wasn't an emphasis so much on disaster recovery. One of the reasons was that a lot of the people who were doing Kubernetes were very, I'd say, advanced users because it does take quite a bit of effort. And so they were developing all sorts of scripts and also things like that. But I think what's important to note here is as Kubernetes grows and more people are using it, we're going to need tools which are easier at a glance so that these tasks can be done by more people, not just the person who's got all the certifications. So that's another reason why Kasten reminded me so much of Veeam when I first saw it, because it was intuitive. So anybody with a kind of background in IT and background in data protection, can figure it out. And I think that's very important. I think we'll see that now with your demo as well.
Okay, so let's talk a bit about Kasten. Very briefly, just a short introduction. Kasten is a Kubernetes data protection solution from Veeam. It's actually the number one in the market at this moment, and it's designed from the scratch to work in a Kubernetes environment. Actually, Kasten itself is a Kubernetes application, and the idea is to protect, of course, all your applications running on your Kubernetes cluster. We have a very wide support. So basically, we support almost any kind of Kubernetes distribution, OpenShift, Rancher, Tanzu, all the cloud providers, Amazon EKS, Google Cloud, and so on and so forth. With multiple support for different kind of storage solutions, we provide also consistent backups for different databases by using canister blueprints. Maybe that could be the subject for another session. And of course, different security features like immutability, encryption, and more. Kasten has 4 main use cases. The first one is backup and restore, of course, that is the main one. But there is another one, which is the focus of this presentation, is disaster recovery. How we can recover after a disaster, after the whole cluster is down, right? Also, the same strategy can be used for application mobility. We can talk about that. Also, how to migrate application between two different clusters. And of course, ransomware protection, because if in Kubernetes, you are not free of having a ransomware attack. Okay, so you also need to protect your data running on Kubernetes. So for disaster recovery, we can use Kasten to provide the tools, to provide the strategies to recover your applications in another cluster, right? It could be in the same or in a different Kubernetes distribution, could be in another location. For instance, you can have your applications running in Tanzu on premises, and then you can have your disaster recovery cluster in AWS using EKS, okay? Or whatever combination you want. Okay, that is the idea. Okay, so you have freedom of choice to recover your applications after a disaster. We have two different strategies for disaster recovery with Kasten. Okay, and it depends on your requirements for basically your SLA, but also has some implications on the cost of the infrastructure, not about Kasten, but about the infrastructure itself. We're going to demonstrate both scenarios in this session. It's going to be very quick. The first strategy is using the rebuild strategy. So, for instance, here in the slide, you can see we have a Kubernetes cluster with multiple applications, and we have Kasten, right? The very first thing Kasten is going to do is to take a snapshot of the applications, right? And then the information about this restore point is going to be kept in the Kasten catalog. Right? Kasten has a backup catalog, which is very relevant, and we're going to mention in a minute. Then we can export this snapshot to a location profile, basically a backup repository. Could be object storage, NFS file share, could be also, in some cases, be backup repositories. Now, we also can, and actually we should, send a backup of the Kasten catalog also to this backup repository. Okay. Why? Because if we lose the Kubernetes cluster, of course, Kasten is also gone because Kasten is running inside the cluster. And also the catalog itself is gone. Without the catalog, there is no way of restoring the backups. So this is important. You should enable the backup for the catalog, which is basically the disaster recovery feature in Kasten. So we can create policies for both of these tasks. I'm going to show you that in a minute. And what if, this is a bit exaggerated, but what if something goes very wrong with your cluster and your cluster is not available anymore? And now maybe you just have your backup repository somewhere. Okay, let's say in AWS, an S3 bucket. So what we can do is to create a new cluster and install Kasten from the scratch. It's a new instance. From here, we can restore the catalog, right? And after we restore the catalog, we're going to get access to all the restore points. So then we can restore the applications back to this new cluster. Okay, so the steps are not very complicated. Actually, most of them can be done using the web interface from Kasten, but of course can take some time. That's why we are going to talk also about automation. So for this demo, this first demo, we're going to have two. We have a Kubernetes cluster right now running on Google Cloud. Okay, and we're going to have all the backups in a cloud-based object storage. We're going to say, okay, this cluster is gone. I want to rebuild everything. So we're going to rebuild the cluster using Terraform, and we're going to restore the Kasten catalog and also all the applications using Ansible. Okay, the idea is to speed up this process. Okay, so in the very first place, okay, let me again. Okay, no problem. A new
Very good
document.
practice. He signed out beforehand, so it's good. Zero trust.
Yeah, I don't trust in myself. So, okay. So this is the Kasten interface. As Geoff already said, this interface is very, very simple. In the very first place, you can see the applications in this cluster. I have several applications on top of the default namespaces in Google Cloud. Remember, this is running on Google Cloud, right? I have, for instance, a Pacman, a stock demo application. For instance, the Pacman. I can get the service IP address. This is actually public. You can access right now if you wish. So this is the Pacman. And at this moment, I have only one high score, which is actually this morning. I was playing with this just to create this score, right? Just for the demo. In profiles, we can create the location profiles, basically the backup repositories. And I'm using at this moment a Google Cloud backup repository, okay, a Google Cloud storage as a location profile. And I have different policies to protect my applications, okay? I also have enabled here Kasten disaster recovery. Later I will show you how this can be enabled, but when you enable Kasten disaster recovery, you're going to get this ID, and also you need to provide a passphrase to encrypt the Kasten catalog backup. So basically, when you enable Kasten DR, you are enabling the backup of the Kasten catalog and configuration. It's important you keep safe this ID. If you lose this ID, you cannot restore the catalog again, and of course, you cannot restore your applications. Okay, so it's important to have this and the passphrase is safely stored. So for this example, I'm using Terraform. Actually, for the sake of time, I already ran my Terraform script. And this Terraform basically is deploying Kubernetes, is deploying Kasten, and making some additional configuration. And I will show you now. The output is actually showing me here the URL for Kasten. It is also running in Google Cloud. You can see here system information. This is also
Hey,
Google
Patricio.
Cloud.
Patricio, can I ask one
Yes.
thing? Also, those IDs, I think they encrypt the backups too, and that's why I think they're so important, right? So, because some people ask me, well, it's on S3, can anyone just grab my backups? I think they also, don't they encrypt them as well, if I remember correctly?
All the backups are always encrypted by
Right.
default. Okay. By default, Kasten is going to use its own encryption algorithms, but you can integrate, for instance, with HashiCorp Vault or with AWS KMS and other similar solutions if you want to manage your own encryption keys. But you cannot have your backups unencrypted. By default, always are going to be encrypted. Okay. Okay. So we have this cluster. This is the GitHub project where you can get access to all this automation information. So basically, I use this Terraform manifest to deploy a new Google Cloud network, a new storage bucket, the Google Cloud, the GKE cluster itself. All this is going to be deployed automatically with Terraform. According to my test, all this process, including the installation of Kasten with the last release, and some basic configuration about the repositories, for instance, it takes around 20 minutes. So for your disaster recovery plan, you have to consider at least Terraform is going to take 20 minutes in deploying Kubernetes plus Kasten, okay? And basically we get this, okay? Now, this Kasten instance is empty. I don't have application. This is just the default namespaces in Google Cloud. I have a repository, but this is a new one deployed with Terraform. This is not the one used here for my backups. I'm sorry, here it is. You can see the number is a bit long, but here is it ends in 0020, and here is totally different. So there are two different buckets. So for disaster recovery, for this rebuilding strategy, the first thing you need to do is to add here a new location profile. Basically, you need to add this one, the original one where you have the backups. You need to add the location profile here, right? That is the first step. And then you can restore from here the configuration. You're going to be asked again for the cluster ID and the passphrase. The passphrase you use to encrypt the disaster recovery configuration, the disaster recovery backup, right? And after this, you are going to get access to your application backups, and then you need to restore one by one. All this process could take some time, and it's not very nice to be working this for maybe a couple of hours when you can maybe automate this process. So for automate this process, I'm going to use Ansible. And for Ansible, I have two steps. The first one is to create the location profile, the right one, the one with the backups in this new instance, and then restore the applications from the backups, right? I need to consider some variables. This is just examples. You need here to provide the information for authentication, depending on whether you're using Azure, AWS, Google Cloud, it's up to you. But then here you need to provide information like, okay, what is the name of the bucket and the profile where you have the backups, right? And the type of the bucket, in this case, Google Cloud Storage, the region, the passphrase, right? And the cluster ID. So I'm going to use all this information to just restore my configuration here. So I will add this, we'll add this to the kubeconfig, okay. So I'm here in Ansible, and again, here I have the two scripts, the two playbooks. So I'm going to run the first one. The very first one is going to create the location profile, basically the bucket, and it's going to restore, it's going to run the restore for Kasten, okay? So just give it a second. Okay, now it's done. So if I wait here, okay, now you can see the restore is in progress. This is going to take maybe 2 minutes. In the meantime, we can check here how this works. In the restore application, basically I'm asking to, I'm sorry, this is the first one. Creating the location profile, which could be AWS S3 or Azure or Google Cloud, depending on which variable I'm using here. In this case, I'm saying this is Google Cloud Storage, okay? And then down here, I'm just saying, please run this. This is a bit small. That's better. This playbook. This is here actually. Sorry, here. And this is basically going to create a secret with the passphrase, right? And then I'm just going to say to Kasten to run the restore process with this cluster ID. And this is the profile name. This is basically the repository where I have the backups. The second step is going to run this to restore the applications. This one is going to basically check all the restore points available, okay? And then is one by one is going to create a namespace and restore the restore point, basically the application, okay? So let's see, this should be ready very soon. Now it's important to provide the proper variables here. let's see here also in Terraform. For Terraform, I'm providing in the same GitHub project the the manifest for AWS, Azure AKS, and also for Google Cloud. So whatever you're using. In this case, remember, we're going to be, I'm going to back to the presentation. I'm going to be recovering in Google Cloud. So the original cluster was in Google Cloud, the recovery also in Google Cloud. And here you can see the QR code. If you want to get access to the GitHub project, you can also do that. Okay. So let's see, this is almost done. Okay. I don't know if you have any questions so far. Geoff, if you want to say
Yeah,
anything
I'll
in the
point out
meantime.
that this interface has gotten a lot better, folks, because when I first tested this years ago, the screen would die. Um, it wouldn't, like, now it's got this casting in progress. It was all nice, but there'd all these error messages popped up, and I was like, oh my, what did I do wrong? But they've really smoothed this out, so it's gotten a lot easier. Someone's asking about the PowerPoint presentation. Ahmed's asking, will you be able to share the PowerPoint?
For me, it's not a problem. Yeah, we
Sure.
can do that.
We'll make sure we've
Later on,
got
we can see how we.
all his passwords in there for his Azure and we're gonna practice for free, right?
Yes, no, that's why I'm showing you here the variables here in GitHub, because all the private information is not here. I cannot show you the right one. Okay, so you can see here the restore is complete. Okay, so now if I go to location, now I can see I have another location profile. This is basically where my backups are stored, right? If I go to policies, the original policies are here. I'm just going to revalidate. They're just all fine. So basically, I restore all the configuration. If I go to the applications, I can see there is no applications. Where are my applications? Remember, the disaster recovery feature is just going to restore the catalog, not the applications yet. So if I go here to remove applications, I can see I have the backups, okay, my restore points. So now I should restore all of this. But of course, again, this is a demo. I have only 4 applications, but in a real environment, you can have dozens or even hundreds of applications. You cannot do this one by one. So again, you can leverage Ansible. So I can use the second playbook, and the second one is going to basically read all the catalog, the restore points, and it's going to start the recovery process. Okay, it's going to launch the restore in Kasten. Actually, now is okay. It's done. So if I go back to Kasten, to the dashboard, I can see here in a second. Okay, now the restore is running. So in a couple of minutes, you're going to see here all the applications are restored again in one single step. With one single command, you were able to restore all the applications. Okay. So in the meantime, because it's going to take you still some minutes, and I don't want to have you here waiting, we can discuss about the second scenario. Let me go back to PowerPoint. The second scenario is basically a replication scenario. Okay. In this case, we have a first cluster, just like before, with all the backups in a specific bucket. And then we have a second cluster, right? Working in parallel, okay? Also with Kasten. And what we can do is to import the applications from the backup, okay? And we can schedule this import. So let's say I can import every day or every hour. It's going to work like replicating the application. So in the first cluster, you're sending the backup to the repository. In the second cluster, you're importing the backups in the second cluster. So it's just like replication, having both cluster active all the time. That's why this strategy is more expensive, because you have 2 clusters running at the same time. The second cluster could be smaller, I mean, with less nodes, and then you can scale out after the disaster. And the idea here is you import everything. So you have your applications also in the second cluster. So if the first cluster fails, again, you have your second cluster working all the time. Okay, and you can just maybe redirect your DNS records or whatever you need to make sure the users are using the applications now in the second cluster. Okay, so for this demo, we have the same source cluster, the Google Cloud cluster. Okay, now we have the backups again in Google Cloud Storage, and we're going to replicate all the applications in AWS. So remember, Terraform was used to create the cluster and install Kasten, and then we're going to use Ansible to create all these import policies and to replicate all these applications, right? So in case the first cluster is gone, the second cluster is ready to use immediately. Okay, so it's slightly different than before because you don't need to rebuild after a disaster. This is going to be already there. Okay, so let's go back here to the demo. Okay, the recovery is almost done. Okay, Pacman is already restored. Let's see if this is right. So let me see the IP addresses for the. Okay, this is Pacman. So I can open here, and I have my Pacman already restored, and with the right data. This is in a database, so okay, I was able to restore my applications after a disaster with, in this case, with Terraform plus Ansible. Now, let's move to the next example. The next example is with the AWS. So I have another cluster here. This is the output for Terraform again. So this is AWS. I'm going to, okay. So you can see no applications here. System information, I'm using EKS. And actually, if I go to the profiles, I have AWS S3 bucket as a profile. I'm not using Google Cloud. This is a whole new cluster, okay? So this is the project for this replication example. Also, you have the Terraform manifest here for you to use. For Ansible, this is a bit different because first, you also need to create the location profile containing the backups. So here in this EKS cluster, I need to add the Google Cloud Storage because there I have all the backups, of course. I don't need to enable the disaster recovery feature because this is not using that strategy. I'm just going to replicate the applications, right? Then I'm going to create imports. The import is a kind of policy you can create in Kasten. If I go here, for instance, this is the AWS cluster. I'm going to policies, and I can create a new policy, and I can import an application. For import application, what I need is from the source cluster, for instance, this is the Pacman backup, I need this string. This is the importing string. This is required here, okay? With this, I can create the import policies and I can run the import and the restore of the application. But again, I need to do this one by one. This could take some time, okay? Which is not very nice, of course. So the idea with this project, again, using Ansible to automate this process. Now, in order to create the imports, I need, as a previous step, to collect this string for every policy. For that, I'm going to use basically a kubectl command, a very long one here, as you can see. Okay, this one. But first, I'm going to move the kubeconfig here. So I'm going to change to AWS. Oh yes, I'm using AWS now. Okay, so with this Okay, but this is not what I want. Sorry, that was my mistake. I need to go to the first to the production cluster, to this one. Okay, this is in Google Cloud. It has only one node. So here I'm going to run this command, this one, and this one is going to bring me this. These are basically the name of the policy, the string, and the application name. I need to put this in a CSV file, like the one you can see here. You need to add the headers here, so this is important. So you can see here the policy name, the string, and the application name. And my playbook here is going to read from this CSV file, and it's going to create the policies using this data. Okay, so I will move back here to AWS. Yes, I'm working with AWS. So the very first step is to create the location profile, right? So this is just going to create the location profile, and if it's needed, it's going to create also no, that is later, a transform for the import policy. I will explain that in a minute. So now all that was done here was now I have two location profiles, the one in AWS and the one in Google Cloud, which I'm going to need to restore all my applications. Okay, so that is the first step. I still don't have anything more than the profile. So the next step is to import the policies. Right? So I'm going to create the import policies. I'm going to run the second playbook. Basically here again, it's reading the CSV file and it's going to create the import policies. It's not going to restore anything yet. So here, if I go to policies now, I can see I have my import policies. Okay, and it's using, as you can see, the Google Cloud Storage because there is where the applications are stored, the application backups, right? So now I have the import policies, but still I don't have a backup. Sorry, the application restore. The replication is not ready. This import policy is going to run every day automatically according to this configuration. I can change that to run every hour if you wish. And I can force now also to run the policy. But before that, one thing very important, the original application was running on Google Cloud. Now I'm going to import the application in AWS. In AWS, I have a different storage class for Kubernetes. Okay, I can see here storage class. The storage class is this one, the CSI for using EVS, right? But in Google Cloud, it's not using that. So the application, by default, when I try to import the application here, is going to try to use the original storage class, which doesn't exist, right? And it's going to fail. In order to prevent that, this playbook also create a transform set. This was created in the second step, right? And this transform, which is what it's going to do, is to change the storage class. Basically, it's going to modify the persistent volume claim for every imported application. And basically, we're going to change the storage class name for this name. How can I provide this name? Well, basically, in the Ansible project, if I go to variables, here I need to provide the storage class name. So basically, the playbook is going to take this name to restore to configure the transform, and this transform is going to be used for the import policies. If I go here, if I'm correct, yes, you can see that the policy is already configured to use this transform So as soon as I restore the applications, Kasten is going to use this transform to make sure the applications now are using the AWS CSI driver, okay, the AWS storage class, okay? So again, I don't want to run all this manually. The idea here is to automate this process because remember, in a production environment, maybe you can have hundreds of applications. So again, I have this last step, which is just restore applications. Basically here, it's going to run all of these policies, right? So if I go to dashboard, and now you can see the import is running, and then after the import, you will have the application also restored, right? This will take some minutes. In the meantime, I will do something else here. Any questions so far? No question?
Yeah, I think, Patricio, this is kind of what Veeam like to call mobility, cloud mobility and no vendor lock-in, right? This is the same philosophy. So you can use those transform
Exactly.
sets so that you're not imprisoned in some horrible, well, I won't say horrible, but expensive contract and you can't get out of it.
And if you put attention on this, you can realize you can not just replicate the application. This exact same strategy can be used for migration. Let's say, as you mentioned, the freedom of choice we provide with Veeam. Um, I'm using Google Cloud and I want to move to AWS. I can just follow the same process to move my application from one cloud to another, right? So the idea is not just to provide backup and restore, but also disaster recovery and application migration. So, okay, okay, but this is still working. Give me 1 second. I just want to show you this too, for you to compare to, so you know this is true. This is the original application, the original IP address. This is the restore with the rebuild strategy. And the last one is going to be when this is complete in and this will be the in AWS. This is the one. This is the actually this is not IP address. This is IFQDM, but this is still recovering. So okay, this is in theory complete. So the application is back and also with the same data. So that was the idea. It's not just to make sure the application is back and running, that is easy, but make sure also the data was protected. Okay. So yeah, basically that was what I want to show you. Here again, this GitHub project is totally public, so you can get access to the Terraform manifest, also to the Ansible playbooks. The idea is to automate as much as possible for disaster recovery. I mean, whenever you get a call because something is going wrong, because the cluster is down, you have all the pressure on you to restore everything as soon as possible. So automation is key, to reduce the human error because, let's say you get a call 2 a.m., you're going to be very tired, so it's going to be very easy to make mistakes during the process. But if you just need to run a script or a playbook or whatsoever to automate the process, it's going to be way easier, okay?
Yeah, and I'll add on to that. I think I saw it when not. Someone was asking me about, well, how do you get near, almost like near CDP replication? Well, you don't, but I think what you can do is you can have a restore process. Well, I think you probably mentioned this, and then have the replica set at 0, so that it's doing a
Uh,
constant import and a restore and set to 0. Does that work?
It depends on the frequency you set here. I think is
Right.
the minimum is every 5 minutes. So you can back up every 5 minutes and import also every 5 minutes.
Right, right.
Okay.
And then even if you
So that is
didn't do
the
it every 5 minutes, but you wanted to be able to come up as fast as possible, if you did that every 10 minutes and then had a import restore job on the other end. But again, using a transform like Patricio used the transform for storage class, there are more transforms. And one of them is you can play with a number of replicas. And so, yeah, another thing I'll mention here too about his great work is that I actually copied him. I actually asked his permission first though. Because I want to say, hey, I wonder if I can do this to K3S or something. And so I asked Patricio, and then I used it just for fun, and it worked. So his scripts, you can tweak them and send them wherever. It's that's the beauty of this kind of mobility.
Yes, and as you mentioned about the transforms, another very common transform in this replication scenario is, let's say, the second cluster you want to reduce the cost. So instead of having, I don't know, 10 nodes, you have only one or two, right? So you don't have many resources. You can import and ask Kasten to reduce the number of replicas for the applications. So let's say you can import the application but with 0 replicas. So the application is restored, but it's not actually running. You don't have any pod. It's 0. So after a disaster, you can just, again, scale out. You can configure the deployments to have as much as replicas as you wish. So, and of course, you can scale out the cluster itself. Okay, so you don't need to have exact size for both clusters. The disaster recovery cluster could be smaller, no problem. Okay, so actually here, let me show you here. If I go to transforms, I have I can create new transform. Oops, no. I can import a new one, an existing one maybe. For instance, there is a scale deployment example. This is very interesting. You know, okay, so basically what is doing this transform is to modify the deployment, and it's going to replace again the number of replicas here. So I can say, okay, 0. So when I import the application with this deployment that maybe originally has multiple replicas, it's going to be recovered with 0 replicas. So it's not going to consume resources. So you can have a very small Kubernetes cluster. And then after a disaster, you can just scale out this cluster and the applications to have multiple replicas.
I noticed in there too, you've got things like ingresses, because people ask, well, Geoff, there'll be a different ingress, let's say a different ingress controller. That's all there as well. So it's incredible the stuff that it allows you to do.
Yes, actually, so far, I mean, you can modify almost anything in every artifact in Kubernetes. What you cannot do with a transform is to change the type of artifact. For instance, the most common example where transform doesn't help is if you have, for instance, OpenShift using deployment sets, and you want to move to another Kubernetes which doesn't have a deployment set. You have deployments, right? Transform cannot help with that because they are two different the objects, right? You can modify anything in the deployment set, but not the type of artifact. The type is deployment set. That cannot be changed with transform. Okay, so that is the limit you can get with transform. But anything else, anything in the specification of any Kubernetes artifact can be modified by using transform.
Yeah, no, that's a really powerful tool. And I said I played with this, and it's the fact that you can automate like that. Patricio is totally right. I mean, a lot of us in our current jobs or previous jobs were in operations, and you know that the worst thing to happen to you is like at 2 or 3 in the morning, you've got to do something, and there hasn't been enough testing, and guess what? It doesn't work. Figure it out. So this really makes our lives better. And I think going forward with all the threats, and one thing to also underline here is that the threats that exist for other IT workloads exist for Kubernetes as well. So there's been cases of Kubernetes ransomware and things like that. So it's not something to take lightly, unfortunately. And so you want to test it just like with Veeam as well. Like Veeam, normal Veeam software. I would say normal Veeam software. This is normal Veeam software as well. But I'm talking about, if you're talking about VBR, Veeam Backup Replication, there's all sorts of testing capabilities there. And we have the same thing here as well. So Patricia, now we got about 10 minutes left. Since you work at Veeam, do you know anything about the future that's happening with Kasten? Any inside information you can tell us? I hate to put you on the spot, but I always do this.
No, actually, I don't have much information about Kasten. I know we are working a lot with making improvements in how to protect, for instance, OpenShift virtualization, right? With OpenShift, you can have not just containers, pods, you can also run virtual machines. Okay, this is a hot topic after all this Broadcom VMware stuff. So some customers maybe can move, if they have already OpenShift for Kubernetes as a Kubernetes environment, they can also run virtual machines on top of it. Kasten already support that. Okay, the support still is very basic, but we do support it. And the idea, of course, is to make things better. Okay, to make it like a real solution to back up these virtual machines, which is not very simple because it depends also on some Kubernetes standards and specifications. So it's not just up to Kasten; it's also up to Kubernetes itself. But we're working a lot in that direction, and a lot, of course, in different integration for security purposes with CM solutions, for monitoring, for logging, more integration for KMS, that kind of thing. Security is a very big deal for us in Veeam, also for Kasten. So that is one of the things we're working on. I was checking some questions here. Jack was asking about the licensing. Yeah, for the second scenario, for the replica scenario, unfortunately, in this moment, you need to have licenses for both clusters. Okay, so it's a good idea to have a small cluster as for disaster recovery. Then you can scale up and use maybe the license of the original cluster when the original cluster is gone, of course, when it's done, right? But if as soon as you have Kasten installed, installing two clusters, you need to license both clusters. Now, the disaster recovery cluster, if it's less than 5 nodes, you can still use the free license. With Kasten, if you have a cluster with maximum 5 worker nodes, you can use the free license. So you are not forced to pay a license if the cluster is smaller. Okay. And there is another question about private container image registry. Yes, I mean, whenever we restore an application, Kasten basically is going to restore the Kubernetes manifest, for instance, the deployment manifest, the YAML file, right? And then Kubernetes needs to pull the image. So the cluster where you're trying to restore your application also needs access to the image registry, okay? It could be the same, could be different, but you need access to the images, okay? That is important.
Yeah, those are excellent questions. Obviously, licensing always comes into play.
Yes, always.
So if anybody else has any other questions, this was a fantastic show. And folks, going forward, this is what we're going to try to do, make these more informative and deeper, because the original setup Kube Corner was just to kind of expose Kubernetes to everyone. Now I think we've got quite a big group of people who have already started their journey in Kubernetes. So that'll be a lot of fun. And yeah, so if there are any other questions, otherwise, I don't know, and we could wrap this one up. And I say thank you, big thank you to Patricio. Let's just see any more questions. Watch the chat. So I think that's it. Thank you very much, everyone. And we will see you next month. I'm not going to say who's coming next month. I want to keep it a secret. go to the Kubernetes Community Hub. Not Kubernetes, the Veeam Community Hub. This is what happens. It's contagious, right? Go to the Veeam Community Hub and check out the Kubernetes Korner. Please, if you want to post there, also, I encourage everyone to post because we're always looking for new ideas and whatnot. And we will be in the Veeam Community Hub events posting when and who and what we will be talking about in the next shows. Okay, thank you very much. And again, big thanks to Patricio.
Thank you very much.